Okay, another R session, also on classification. This time we're going to look at K-nearest neighbor classification, which, it's one of those tools. It's a very simple classification rule, but it's effective a lot of the time. There's somebody, some experts have written that K-nearest neighbors do the best about 1/3 of the time. And it's so simple that if you, in the game of doing classification, you always want to have K-nearest neighbors in your toolbox. Okay, so we've got a little session here that we'll run. And if we go into our R Studio session, you see we've got it set up here for K-nearest neighbors. And for that, we'll use the class library. So we go library class, and that sets us up for doing K-nearest neighbors classification. And let's ask for help on K-nearest neighbors. And we see the help file, which again is always a useful thing to do. And it tells us it's got a slightly different format to the previous session where we used LDA. It doesn't take a formula. It asks for the training X variables, the test X variables, and the class label for the training. And then it asks for what value of K you want. And then there's some other arguments. Okay? So we'll use this again on our stock market example. So in this case, since we're going to have to list all these variables by name in the call, we'll just attach stock market. And recall, when you attach a data frame, it makes available the variables on the data frame by name in your frame. So if I go down into the session window here and say ls, well, that didn't do it actually. I can say objects 2, because stock market's in position 2. There we go. So they're available. They're in location 2 on the search list. And there's all the variables in S market available by name. Okay. So what we'll do is we'll make a matrix of lag 1 and lag 2. We're going to use the same two variables we used in the previous session. So we'll say xlag is cbind. That makes a matrix with 2 columns in this case of lag 1 and lag 2. Okay. And let's just make sure that that actually did what we want. I mean, I know it did, but let's look at the first 5 rows of that matrix. And there they are. So it did what we wanted. And then we'll make a indicator variable train, which is year less than 2005. So that's just going to be a binary variable of trues and falses, depending on whether the variable year was less than 2005. Okay, now we're ready to call KNN. So we give it our matrix xlag, and right in line here, we index it by train, which says just use the training observations. And then for the test observations, we give it xlag not train. So those not train will be, therefore, those that are equal to 2005, right? For year equal to 2005. So train and not train, that exclamation mark means not. And the response is direction, again, indexed by train, and k equals 1 says we want 1 nearest neighbor classification. And again, just to remind you, that means what the algorithm does is it says to classify a new observation, you go into the training set in the X space, the feature space, and you look for the training observation that's closest to your test point in Euclidean distance, and you classify to its class. Okay? And so this will do it. And we can look at we put the results in knn.pred, and we can do a table of knn.pred and the true response, which is direction at not train. And we get a little confusion matrix again. And we can look at the classification performance there. And it's exactly 0.5. So it was useless. 1 nearest neighbor did no better than flipping a coin. So what to do next? Well, one could proceed further and try nearest neighbors with multiple values of k. We haven't done that in this session, but we leave it up to you. And you can look in the end of the chapter and you'll see that there's examples of this.